Okay, let's get started. So, homework 2, as you know, is due on CCLE by midnight tonight. I have my office hours after class, so if you guys have questions about the homework, we can certainly talk about it in office hours, but in a moment I'm also going to see whether you have any questions that you want to ask now. I want to say one word about the next homework assignment. It's actually a programming project. I think that should already be up on the CCLE's site. The basic idea here is that I think we went through in class earlier to kind of get the sense of different programming languages that people prefer for doing the programming assignments. And my memory was that there weren't very many different languages that people picked as their favorites. So I guess the basic idea here would be that go ahead and use whichever language you prefer. If it requires compilation like C, C++, please provide a make type script for actually compiling the executable. There's details in the project assignment about kind of the little details that we'd like you to follow for exactly how to do that. We're going to go through some concept exercises today. This should sort of introduce you to the general idea of the project, which is basically to implement kind of probabilistic models for scoring the strength of evidence for single nucleotide polymorphism candidates, basically in a bunch of short read data. We tried to sort of simplify the input data for you so that you won't have to be dealing with actual, base call output files from sequencing machines, but you'll basically be getting some numbers that come in that sort of score the quality of the base calls. So our approach here will be basically to run some automated tests on your code on various kinds of input cases. I believe that we supply for your own testing a set of, 5 or 10 input files that you can run as input just to see whether you think your code is behaving the way it should on various kinds of simple situations. Of course, testing, assessing whether you think your program is doing what it's supposed to do, is very much part of the assignment. I mean, in other words, figuring out for yourself whether you think your code is doing what it's supposed to be doing on the test data. So one way of saying that is we're not actually providing the right answers for the test data, we're just providing the input test data. Okay. Any questions? Well, I think nowadays we have to be sort of allow both Python 2 and Python 3. Different people are using one or the other. So I would just say, Python. If you're using Python 2, use Python 2.7, kind of the latest release. I guess I'm actually, because I don't use Python 3 that much myself, I'm not sure how you specify in your source code that you're expecting Python to be run under Python 3 versus Python 2. Did I answer the question? You can use either Python 2 or 3, but I guess there should be some kind of flag in your code that would indicate which it is expecting to run under. why don't we get a show of hands here to see who would be doing it under Python 2 versus who would be doing it under Python 3. Who would be doing it under Python 2? Okay, a few people. And what about Python 3? Approximately equal number of people. Maybe we should touch bases about how exactly that should be specified by their code, and we'll put up. Yeah, but we should decide on like a really clear mechanism so that there's no question of getting it wrong. Okay, well, thank you for that question. What we'll do, I guess, is post something on we'll post an announcement through CCLE about, and we, I guess, conceivably might update the project description. Thank you for that. Other questions?
Kios are all mathematics?
So, as I said last time when this question came up, you can, but clearly you need to implement the calculations yourself. In other words, it's not just a matter of saying, okay, I'm going to use this library. It'll take care of all this for me. So take a look at the project. You'll see that basically it's about implementing a model, two different probabilistic models, one more sophisticated than the other, for how to take into account the strength of evidence in the data, and you're going to implement the calculation as it's described in the project description. So take a look at that, but you can use our math. Other questions?